Okay, so question 6. We have a few values that are important to note. So first is the mass of the car, which is 1.2 times 10 to the power 3 kilograms. And then we have the mass of the SUV, or in this case, I'll just call it truck, 4.1 times 10 to the power 3 kg. And then finally, we have the velocity of the car, which is 27.5 meters per second. So what I did is that the velocity was actually given in kilometers per hour, but I divided it and turned it into meters per second, divided by 3.6, remember? Now, in this question, what it's saying is that the kinetic energy of the car is equal to the kinetic energy of the truck. Therefore, we can rewrite it as the kinetic energy of the truck is equal to 1 over 2 mass of the car into the velocity of the car squared. And so all we did is that we kept this EKT. However, we expanded EKC and we got our typical 1/2 mv squared. So what we're going to do is we're going to solve that because we have those values. So 0.5 into 1.2 times 10 to the power 3 into 27.5 squared. And so what this should give you is basically saying the kinetic energy of the truck is equal to 453,750 joules. Now, next up, what we need to do is that we need to figure out the velocity of the truck. And so in order to do that, we know this equation right here. So we know this equation over here, and we already found the kinetic energy of the truck. So we'll substitute all the values we know, and we'll isolate for the velocity, and then eventually we'll find the velocity. So let's do that right now. And then what we're going to do, we have to isolate, so we'll divide 2050 on both sides. And so we get and then in order to isolate the velocity of the truck, we need to root each side. And so what we should get is the velocity of the truck is equal to 14.8 meters per second. However, the answer may require us to write it in kilometers per hour. Therefore, what you would do if the answer does tell you to write it in kilometers per hour, then just do 14.8 times 3.6. And you should get 54 kilometers per hour.